Imagine this. 48 years ago, humans sent a machine into space. And amazingly, that machine is still alive today. Its battery has never been replaced, no mechanic has ever visited it, and no human could reach it to refuel it. So the question is, how has Voyager kept running for all these years? Does it have a battery that never runs out? Or is there some kind of generator whose fuel has somehow lasted until today? And what about solar panels? Voyager has those, but they are no longer useful because it has traveled so far from the sun that sunlight there is incredibly faint. So where is its energy coming from? And there's an even bigger question. If Voyager never collides with a planet, star, or asteroid, could this machine keep drifting through space for billions of years? In today's video, we'll uncover this mystery. But first, you need to know the part of Voyager's story that gave humanity a once-in-a-lifetime opportunity in 1977, one that comes around only once in roughly 176 years. The story begins in 1977. At that time, NASA scientists were presented with an extraordinary opportunity. The four outer planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, were aligned in such a way that if a spacecraft was sent along the right path, it could use the gravity of one planet to reach the next. In other words, the spacecraft would not need to burn fuel every time. The planet itself would give it a push. This technique is called a gravity assist. Imagine gaining speed from one planet, reaching the next, then using that planet's gravity to gain even more speed, and continuing onward, passing one planet after another. But here was the real twist. This kind of alignment happens only once in about 176 years. If NASA had missed the opportunity in 1977, the next one would have arrived around 2153. That means a person born at that time might never have lived to see another planetary opportunity like it. So NASA decided to send not one, but two spacecraft. They were named Voyager 1 and Voyager 2. But here's the fun part. Voyager 2 was launched on August 20th, 1977, while Voyager 1 was launched 15 days later on September 5th. Now think about it. Why was the spacecraft launched first called Voyager 2? And how did the one launched later become Voyager 1? The reason was not the launch date, it was the mission. Voyager 2 was supposed to fly past all four planets, Jupiter, Saturn, Uranus, and Neptune. Its route was longer. Voyager 1, on the other hand, was primarily sent to Jupiter and Saturn, but it had one especially important target, Saturn's largest moon, Titan. Scientists wanted to study Titan's thick atmosphere up close, and Voyager 1 was supposed to pass extremely close to it. But that encounter completely changed its route. Titan's gravity altered Voyager 1's trajectory so dramatically that it could no longer travel toward Uranus and Neptune. In return, though, it gained a major advantage. Its speed increased, and Voyager 1 began heading directly out of the solar system. So the Voyager launched 15 days later eventually overtook Voyager 2. Today, Voyager 1 is the farthest traveling spacecraft ever made by humans. But from here, the story becomes even more unbelievable. Just how far has Voyager traveled? How far away is it now? The moon is about 384,000 kilometers from Earth, and the sun is roughly 150 million kilometers away. But Voyager has traveled so far beyond these that these distances now seem tiny by comparison. Voyager 1 is now more than 25 billion kilometers from Earth, moving forward at about 17 kilometers per second. Voyager 2 too has traveled more than 21 billion kilometers away. To truly feel this distance, imagine one thing. If we sent Voyager 1 a message today, the signal could take about 23 hours to reach it, and another 23 hours for the reply to come back. That means simply saying hello and receiving an answer would take almost 2 days. But you still haven't imagined Voyager's true distance.
Consider another comparison. Suppose we could somehow stop Voyager where it is today, then fly toward it in a modern passenger airplane traveling at about 900 kilometers per hour. Even then, it would take roughly 3,200 years to get there. Yes, 3,200 years. But Voyager's greatest mystery is not its distance. The real mystery begins now. Voyager's story is not just about how far it has gone. This is the part that carried it beyond the solar system. When did Voyager leave the solar system? In 2012, Voyager 1 crossed an extremely important boundary. This was the region where the sun's influence had become much weaker. Beyond it, Voyager 1 entered interstellar space, the space beyond the region dominated by the sun. About 6 years later, in 2018, Voyager 2 crossed the same boundary. But understand one very important point. Interstellar space does not mean leaving the galaxy. Voyager is still inside our Milky Way galaxy. It has only left behind the region influenced by the sun. And where it is now, sunlight is so weak that generating useful electricity with solar panels is practically impossible. So the question remains, where is Voyager getting its power? This is where Voyager's remarkable technology comes into view. Voyager has no solar panels, and there is no petrol or diesel-powered generator attached to it either. Its power comes from a special system called an RTG, or radioisotope thermoelectric generator. Inside it is a radioactive material called plutonium-238. Here's the amazing part. Plutonium-238 constantly undergoes radioactive decay, and that process continuously produces heat. The RTG converts that heat into electricity. No engine is spinning, no fuel is burning, and no solar panel is waiting for sunlight. The radioactive material simply keeps producing heat, and that heat is gradually converted into electricity. This technology has kept Voyager alive for nearly 50 years. But there is a twist. An RTG's power does not last forever. Voyager's power is steadily declining. When Voyager was launched in 1977, its RTGs were producing about 470 watts of electrical power. But plutonium-238 slowly decays over time. That is why the available power decreases a little every year. Today, Voyager has only enough power left to run its essential systems. So NASA has had to switch off some of its scientific instruments, one by one, so the remaining electricity can be reserved for what matters most, the computer, antenna, and communication system. Scientists are constantly conserving energy to keep Voyager alive. Now for an interesting comparison. An ordinary smartphone today is millions of times more powerful than Voyager's onboard computer. Yet a smartphone gets upgraded after only a few years, while Voyager's computer has been working for nearly 50 years. Why? Because Voyager's computers were built for reliability, not speed. Voyager has three main computer systems. One controls the spacecraft, another manages its scientific instruments, and the third monitors the spacecraft's other systems. These computers were designed to withstand radiation, extreme cold, and decades of continuous operation. That engineering is exactly what is keeping Voyager alive today. But what is still pushing Voyager forward? You may be wondering, if Voyager's engine is switched off, how is it still moving? The answer is gravity assist. At launch, the rocket gave Voyager its initial speed. After that, the gravity of enormous planets like Jupiter, Saturn, Uranus, and Neptune was used to change its trajectory and increase its speed. In other words, the planets helped Voyager move forward. And once a spacecraft gains that much speed, the mere absence of air and friction in space means it does not need to keep its engine running. That is why both Voyagers are still traveling through the depths of space without burning fuel. So why are Voyager 1 and Voyager 2 traveling in different directions? If we looked down on the solar system from above, Voyager 1 would be heading in one direction, while Voyager 2 would be heading in another. Voyager 1 mainly studied Jupiter and Saturn, then, after passing near Titan, continued outward from the solar system. Voyager 2, meanwhile, completed a journey that remains historic even today. It studied Jupiter, Saturn, Uranus, and Neptune, all four outer planets, before heading toward interstellar space. So when it comes to achievements, I believe Voyager 2 deserves full credit as well, because it observed all four outer planets up close. Voyager did not merely travel, it discovered new worlds. The Voyager missions changed many of our old ideas about the solar system. One of the most shocking discoveries was Jupiter's moon Io. Voyager saw active volcanoes there. For the first time, humans had clear evidence that active volcanoes exist beyond Earth. Io is filled with continuous volcanic activity, and this discovery became one of Voyager's greatest scientific achievements. But how does a signal travel all the way back to Earth from that far away? Voyager does not have a massive transmitter, so how can its signal reach Earth from billions of kilometers away? NASA does it through the Deep Space Network, or DSN. It is a network of enormous radio antennas located in different parts of the world. Some of these antennas are so large and sensitive that they can detect even the incredibly weak signals coming from a distant spacecraft like Voyager. By the time Voyager's signal reaches Earth, it has become extremely faint, and yet we can still hear it. A spacecraft nearly 50 years old is still speaking to us from billions of kilometers away. But this conversation will not continue forever. When will Voyager fall permanently silent? Voyager's biggest problem is no longer distance, it is power. Its available electricity is decreasing every year. Scientists estimate that sometime in 2030, its remaining power will become so limited that operating the scientific instruments and communication systems will be extremely difficult. Then, one day, Earth will receive Voyager's final signal. After that, silence. But remember, its journey will not end there. The signal will stop,
But Voyager will not. Even after the day its final signal reaches Earth, the spacecraft will continue moving through space. There is almost no air and almost no friction, so if Voyager does not collide with a large object, it could keep traveling through space for not just millions, but billions of years. And perhaps that is the most beautiful thing about Voyager. One day, we will stop talking to it, but Voyager will keep moving ahead of us. Will Voyager ever reach another star? Now imagine this. Traveling in the direction Voyager 1 is heading today, in about 40,000 years, it will pass relatively close to a star called Gliese 445. But do not misunderstand the word close. It will pass about 1.6 light years from the star, roughly 15 trillion kilometers away. Voyager 2, meanwhile, will pass relatively close to a star called Ross 248 in about 48,000 years. But even there, the distance will be around 1.5 to 2 light years. From a human perspective, these distances are so immense that they are almost impossible to imagine. But Voyager is carrying one final thing, and perhaps this is the most emotional part of the entire story: the Golden Record. A golden record was sent along with Voyager. It contains sounds from Earth, children laughing, the voices of animals and birds, music from different countries, and greetings in 55 languages. So if in the distant future another civilization ever finds Voyager, perhaps this golden record will tell them that, once upon a time, on a small blue planet in this vast universe, a civilization called humanity lived. A civilization that lifted a small message from its home planet and sent it toward the stars. That is why Voyager is more than just a spacecraft. It may be humanity's farthest reaching message, a machine that will one day fall silent forever on Earth, but may continue its journey through space for billions of years. If you had the chance, what message would you send on the golden record on behalf of humanity?